Hey, welcome to this lecture. This lecture is going to cover compound interest and using time value charts to help calculate that compound interest even quicker and smoother. So before we get into compound interest, I just wanted to do a simple review of simple interest. So simple interest, you probably did it in grade school, probably 5th, 6th grade, was interest equals principal times rate times time. So $1,000 put in the bank at 3% interest for 3 years will give me what interest? That's simple interest. Now, compounding interest that you either earn or you pay takes interest and then snowballs it, so you earn your interest on your interest. Either that can be a good thing if it's a savings account or an investment account, or it can be a really bad thing if it's a credit card or any other type of compounding loan. So for compounding loans or compounding interest, the calculation becomes a little more difficult because it's different than simple interest in that in simple interest you have one calculation. You have principal times rate times time. In compounding interest, you have to do principal times rate times one period, then add the interest to the principal, and then times it by interest, and then another period of time, and then you add it and snowball it, and it grows and grows and grows. So compounding interest, you can do it by hand with simple interest formula plus then just adding the interest each time you have a period. But there's a much simpler, faster, more streamlined approach using time value tables. So for compound interest, first, I think everybody kind of understands compound interest. You're looking at a specific amount of money that you're depositing, and it's going to compound again and again a certain number of times. So using the time value tables on it, well, let's actually do a simple one. So let's say we have $1,000 at 6% interest, and we have it in there for 5 years. Now we could calculate it. Year one, we've got $1,000 times 6% times 1 year. And then we can pull out our basic calculator here, and we can take 1,000 times 6% times 1 year, so $60 in interest, so plus 60. So then in year two we have 1,060, so plus 1,000, so 1,060 times 6% times 1 year gets us $63.60 in interest. So then we're going to bring that down and add that, and then we're going to be at 1,123.60. Then year three, let's do year three, times 6% interest, 67, so times 6% times 1 year. So we're going to get some odd cents here, but I'm going to leave it at that, and we're going to add it in. We're going to add the odd cents, 1.6, even though normally we'd round that off. So 1123.6. So 1,191.016. Okay. And then let's do it for year four. Year four, we have times it by 6% times 1 year, and we got 71,46,096, which we're going to add to 1191.016. Let's start to get really big. This is why we round. 47696. And then we're going for 5 years. Okay. And oh shoot, I shouldn't have erased that. 1262.47696 times 0.06 times just 1 year. So our final interest is 75,7486176 plus 1262.47696. All right, 1,338, 22,831. Okay. So this was year 1, the end of year 1. This is the end of year 2, end of year 3, end of year 4. So this is year 5. Okay. So that took quite a few steps. So the other way we can do it for time value tables, and they're called a couple different things depending on what textbook you're looking at. They could be called compound interest table, they could be called future value of a single amount, or compound value of $1. It really depends on what. They all mean the same thing, they're slightly different wording. Like I said, future value of a single amount, so we're looking towards the future and trying to figure out what that future value is of a single amount that's getting compounded. Or compound value of $1, so we're compounding one single amount, or compound interest tables. Any one of those is the same meaning. So let me show you on a table how we can do these a lot quicker and more efficient. I don't know how well you're going to be able to see that, but in our problem we had 1,000 at 6% for 5 years. So compound tables, you have your percentages usually at the top, sometimes on the side, sometimes you'll have a whole page dedicated to the percentages. Just depends on what type of a table you're looking at. But you identify the interest rate you're earning and the period, so how long it's going to be earning that interest. So in this problem we had 5 years, and then we intersect it with the interest rate. So 6% at 5 years gives us 1.338. I don't know if you can see that, so you're just going to have to trust me, but it's 1.338. So then we take that, I call it a factor, I don't know that it's necessarily called that, 1.338. And then we take it by that initial amount we had up there. And then we grab our calculator again. So $1,000 times 1.338. And we end up with 1,338. So that took us, I don't know, 30 seconds to come up with the answer. This was the longhand answer. Now you notice they're not exactly the same, and you're going to get rounding differences when you use the time value tables versus just doing it longhand, and that's okay. We're talking minimal amounts of change, and we're going to round it off anyway. Even if we had rounded it off, we would have 1338.23, so we would have been 23 cents off. That's okay for these calculations, but it's much simpler and easier to do. You have to identify two things. You need to identify the period of time, so in this case it was 5 years, and you need to identify the interest rate. So you identify those two things and then you intersect them. So wherever they intersect, you get up with this magic factor. Then you take that factor and you multiply it by the number that you're trying to find, and it spits out your answer. It does so quickly and efficiently, and it's much easier than going through all this process that you could make any number of mistakes along the way.